Lesson 314, Area and Volume Ratios. Please remember to give me your course and section number with all communication. This can be found in the upper right-hand corner of the Geometry LMS. If you're watching this video, you're in Geometry 202B. That's your course number. And your section number would be 1, 2, 3, or 4. The objectives in this lesson are to use ratios for areas to find missing dimensions and measures, and use areas to find the scale factor that relates to similar figures. What you have learned in previous lessons is that when all the attributes of a figure or pre-image are multiplied by a particular scale factor, the resulting image is a dilation of the figure. It's either going to be smaller or larger than the original. That dilated figures are always proportional and therefore similar. You've also learned that the ratios of their corresponding sides are equal to the scale factor of the dilation. This is something else that you've learned when you've examined the areas of similar figures. You found that if the attributes of a figure, such as length and width, were multiplied by some multiplier, the area of the new figure would have the area that is the product of the original figure times the square of that number. And that's what you're seeing right here. You got perimeter, your new perimeter is going to equal your original perimeter times the multiplier. Your new area is going to equal your original area times the multiplier squared. This is what we learned in previous lessons regarding changing the attributes to calculate the new area. Also, since you know that the pre-image and image of a dilation are similar figures, you can say that any similar figures are a result of a dilation. The multiplier that the formula refers to is the scale factor of a dilation. So you can replace the term multiplier with the words scale factor in the formula. And this is what it's going to look like. So we've got A2 right here. A1 is going to, okay, so A2 equals A1 multiplied by scale factor squared. Now we can replace the word scale factor with the T. You know, if we don't know something, we've always replaced it with an X. Well, here we're replacing the word scale factor with a T, because what we're doing is we're simplifying our formula. So if you divide each side of the equation by A1, you have a ratio of the areas. Now we've developed a formula for the area ratios of similar figures. And we also found that the ratio of the areas of similar figures is equal to the square of the scale factor. So area ratios of similar figures. We can use this relationship to solve problems. So let's walk through this example that shows how to find the scale factor between two similar figures. We're going to let A1 equal the area of the small triangle, which is 30 centimeters squared. And we're going to let A2 equal the area of the large triangle that equals 67.5 centimeters squared. And we're going to end up with this equation that we've developed, this formula that we've developed, and we're going to plug this information into that formula. So, or rather, we're going to substitute known values into the area ratios formula. That's how you say it mathematically. So A2 was 67.5, A1 was 30, and we're looking for our scale factor. So we're going to divide 67.5 by 30 to obtain the result of 2.25, which equals t squared. So to simplify our variable t, which represents a scale factor, we must calculate the square root of both sides of the equation. And that's why we put the square root symbol above everybody right there. After calculating the square roots, we see that the scale factor t is equal to 1.5. So the square root of 2.25 was 1.5, square root of t squared was t. Now in this example, we're given the areas and the length of one side, but we aren't given the scale factor. Since we know the trapezoids are similar, we can use the area ratio formula by replacing t with LO over AD, which is the ratio of the lengths, and then we can solve for LO. And we've set that up right here. After we replace t with LO over AD, this is what we have. So we've got the area A2 over A1, and we've replaced t with LO over AD squared. We substitute AD with the length of 18, and it looks like we've substituted A2 and A1 with 54 and 150, which are the areas of the trapezoids. And when we calculate the square of LO and 18, we get LO squared over 324 squared. See how the square root, or the square is, or the 2 is outside the parentheses? Well, whenever it's outside, you're going to have to square the numerator, you're going to have to square the denominator, and that's what we've done in this last step. Now we cross multiply. 54 times 324 gives me 116.64. 150 times LO squared gives me 150 LO squared. But I've obviously skipped a step here. I've gone ahead and worked out the math. So 54 times 324, let me get my calculator here. 54 times 324 gives me 17,496. Let me write that in right here. Okay. So 54 times 324, that gave me 17,496. Oh, I knew I would run out of room. There we go. Let's ignore that part. And so then when you divide that by 150, you're going to get 116.64. Ran out of room again. There we go. Just to show you how I got to that step right there. So anyway, we cross multiplied and divided. We got 116.64 equals LO squared. Now we take the square root of both sides. That's why I've got those square root symbols there. And this is going to help us isolate LO. And so we find out that 10.8 equals the measure of LO, so it's 10.8 centimeters long. And that's what they wanted us to find out in the problem. Now let's work some examples. This says, find the scale factor t for each pair of similar triangles with given areas. So what we're going to do here is we're going to let A1 equal the area of the rectangle HIJK, and that happens to equal 24 millimeters squared. We're going to let A2 equal the area of LMNO, which happens to be 54 millimeters squared. I'm getting that information right down here in the problem. It was already given to me. Don't forget your formula. You may want to write this down before you take your next step. The square should be outside the parentheses. I've noticed in some of my explanations that it's inside. It really should be outside. Area ratio formula. That's what I've got written down right there. That's an A, not a triangle. And then I'm going to plug in the information that I know. The area for A2 was 54. The area for A1 was 24. These are going to equal t squared. And that was where I just substituted the information in. Now what you need to do, if you can, is go ahead and reduce this fraction, and we can with this one. That's going to be 9/4 equals t squared. And that's all I did, was reduce the fraction. Or simplify. You could just write simplify there. Now I got to get the square root of both sides. And the square root of 9/4, now remember, you get the square root of the numerator. Square root of 9 is 3. Square root of denominator, square root of 4 is going to be 2. And that's going to equal t. And that right there will equal my scale factor. And that was the information that they were wanting. What is the scale factor? There's your official answer. This next one says find the area of rectangle QRST if the area of rectangle DEFG is 144 square inches and the scale factor is 3/5. So notice in this one, we're looking for the area. They've already given us our scale factor in the area of one of the rectangles. So we're going to let A2 equal the 144 inches squared, and we were given that information right there. A1 we don't know, and T is our scale factor, which is 3/5. So you still use that same area ratios formula. Let's put parentheses around that, keeps life easy. We know A2 is 144. We don't know A1. And then we know that T, the scale factor, is 3/5. Now, I got to go ahead and simplify, because you got to use your PEMDAS here. Parentheses, exponents, multiplication, division, addition, subtraction. So what I got to do right now is my exponents. 3 squared is 9. 5 squared is 25. Now, you're just going to cross multiply. So 144 times 25 is 3,600. 9 times A1 is just going to give me 9A1. I'm going to divide both sides by 9. 3,600 divided by 9 gives me 400. And then here, 9 divided by 9, that leaves me with A1. So my area up here is going to be 400 inches squared. I would rather know the scale factor and find the other area than know the areas and find the scale factor. I think this kind of problem right here is the easier of the two. Here's the official answer, showing you what was going on with each step. Just to summarize, if two similar polygons have a scale factor of t, then the ratio of their areas is t squared. That's what we've learned. So go through and view the LMS lesson 3:14, Area and Volume Ratios, Part 1, and complete the student guide. Read through the lesson and the reference guide, and complete problems 1 through 15 odd. And if you're having problems with any of those in the problem sets, please contact me or attend TOGA before you try to complete the quiz, because I want you to make good grades on the quizzes. And please make note of any general questions you may have when you attend CC on Thursday. And that's the end of lesson 314. Thanks for listening.